Betelgeuse or Betelgeuse, it's a red giant star. If you put it where the Sun is, it would extend out to the orbit of Jupiter. It's enormous, it's very unstable, and it's about to explode. They are among the biggest explosions of radio energy in the entire universe. They generate more energy than a billion suns. Betelgeuse, a red giant star, is so massive that if it were positioned where our Sun is, it would extend out to the orbit of Jupiter. This enormous star is highly unstable and on the brink of exploding. Among the most significant radio energy explosions in the universe, these generate more energy than a billion suns. Located in the constellation Orion, Betelgeuse has fascinated astronomers for centuries. It is much larger and more massive than our Sun, but in recent years, it has behaved strangely, dimming significantly, and even beginning to vibrate violently. This has led to speculations that this once vibrant star is on the verge of exploding in a supernova. However, there is a possibility that we might be witnessing something even more terrifying, a collapse of Betelgeuse into itself. Join us as we explore the latest research on Betelgeuse and its potential implications for our planet. Through this journey, we aim to understand the profound impact Betelgeuse's collapse could have on the future of the universe. Betelgeuse is an enormous star, 950 times larger than our Sun, making it one of the universe's largest stars. However, its massive size comes with a cost. Stars like Betelgeuse have limited lifespans, and Betelgeuse is no exception. It's a ticking time bomb poised to explode, though the exact timing remains a mystery. Situated just 650 light-years away, Betelgeuse has captivated astronomers, shining as one of our closest stars. We marvel at its brilliance, trying to unravel the secrets hidden within its fiery depths. Although only 133% of its radiant energy is visible to us, if we could see its full brilliance, it would outshine even Sirius, ranking as the brightest in our night sky. Imagine a colossal star with a radius 764 times that of our Sun, stretching beyond the asteroid belt and almost touching Jupiter. In this vast realm, Earth, Mars, Mercury, and Venus would be devoured by Betelgeuse's irresistible cosmic allure. But the mysteries don't end there. Every millennium, Betelgeuse sheds a solar mass, casting off its celestial remnant in a magnificent display of stellar theatrics. A nebula 250 times larger than the star itself envelopes Betelgeuse, shrouding it in an ethereal haze that captivates our gaze. This nebula, stretching 30 astronomical units, lures us into a cosmic dance of wonder, beckoning us to uncover its secrets. Let's journey deeper into the heart of Betelgeuse's creation, where the alchemy of hydrogen fusion ignites, birthing helium in a cosmic explosion. Over time, the star's hydrogen fuel dwindles, and a celestial metamorphosis ensues. Helium intertwines with carbon, unleashing a radiance that cascades through the cosmos. But even this grand fusion has its limits. As neon merges with iron, an astonishing transformation occurs. The star's gravity, unleashed by the absence of energy release, triggers an imminent collapse, propelling Betelgeuse toward a fate both inspiring and cataclysmic, a supernova explosion. In the realm of cosmic phenomena, supernovae reign supreme, and Betelgeuse is no exception. With the energy of 10 billion suns, this colossal celestial entity unleashes a force that resonates throughout the cosmos, leaving us in awe of its unimaginable might. Throughout the ages, stars undergo a mesmerizing transformation, transitioning from the vibrant blues of youth to the fiery reds of maturity. It was during the 2nd century BC that Chinese stargazers made an intriguing observation, noting Betelgeuse's distinct yellow hue that set it apart from the celestial tapestry. As the centuries unfolded, the baton of observation passed to the keen eyes of Greco-Roman astronomer Ptolemy in the middle of the 2nd century AD. In his meticulous records, he described Betelgeuse as having an orangish or ruddy appearance, a characteristic that still captivates our attention to this day. This consistent coloration across different civilizations, including medieval observers in the Middle East, adds to the intrigue surrounding Betelgeuse. The tale of Betelgeuse takes another twist as we dive deeper into its enigmatic behavior. The star surprised scientists in 2019 when it suddenly dimmed in brightness. Scientists thought that a large cloud of dust released from the star's surface blocked our view of it. However, the origin of the cloud is still unclear. Some scientists think that a large object, like a planet, might have disturbed the surface of the star or even been swallowed by it. In recent months, Betelgeuse has become almost 50% brighter than its average brightness, an unexpected occurrence because stars usually become dimmer as they age. Scientists are not sure what caused this sudden increase in brightness, but they know that star brightness can change for a variety of reasons. For example, some stars go through cycles of bright and dim phases. The star Mira, known as the Star of Wonder because it changes in brightness, expands and contracts regularly, which changes the amount of light it emits. This is a common occurrence with many stars, including Algol and about 30 others that can be seen in the night sky without a telescope. Deep within the heart of Betelgeuse, a seismic shift was occurring. The explosion of scorching material launched into space created an ethereal dust cloud of magnificent proportions. This celestial dust cloak veiled a significant portion of Betelgeuse's radiant light, transforming it from a dazzling beacon to a subdued luminary in the night sky. Betelgeuse's brightness dipped to levels unimaginable. Once counted among the 10 brightest stars, it now dimmed, ranking lower than the 20th brightest. In recent months, Betelgeuse defied all expectations, challenging the norms of stellar behavior. Scientists and stargazers around the globe have been captivated by this mesmerizing cosmic dance. Theories abound attempting to unravel the enigma of Betelgeuse's extraordinary behavior. Some speculate that massive sunspots or dust clouds are the culprits behind its dramatic fluctuations, while others ponder the possibility of coinciding cycles. Their research exposes the incredible notion that Betelgeuse's supernova explosion has already occurred. Yes, you heard that right. While conservative estimates projected its supernova event to be hundreds of thousands of years away, evidence now suggests a different story. The last observed supernova in our galaxy, Kepler's supernova, graced the heavens centuries ago. Researchers have proposed a model suggesting that Betelgeuse is in the late stage of carbon burning, indicating it may be on the brink of a magnificent explosion. This positions it as a strong contender for the next anticipated supernova event in our Milky Way galaxy. Like a grand finale in the cosmic symphony, Betelgeuse stands as a prominent contender for the next stellar supernova within our beloved Milky Way galaxy. However, understanding Betelgeuse is like solving a puzzle with conflicting observations. There are indications of material ejections and subsequent recovery, leaning towards a mass ejection event, although smaller in scale compared to our Sun. But here's the twist. Supernovae are real phenomena too. We witnessed one in a satellite galaxy of the Milky Way in 1987. So, while our estimates for Betelgeuse's explosion timing may be uncertain, it's not time to plan a vacation around it just yet. The challenge lies in the current difficulty of observing Betelgeuse. Scientists have been studying Betelgeuse for centuries and have found that it has changed in brightness over time. This suggests that the star is aging and could go supernova soon. However, there is not enough evidence to say for sure when this will happen. A supernova is a very bright explosion that happens when a star dies. It is not harmful to life on Earth, and it is safe to watch from Earth with the naked eye. The brightness of a supernova depends on the size of the star that explodes. Betelgeuse is a very large star. A star so its supernova would be very bright. It would be about as bright as a half moon and would be visible during the daytime. The brightness of a supernova would also be a challenge for astronomers. The supernova would be so bright that it would make it difficult to see other stars and planets, making it difficult for astronomers to study the night sky. One possibility is that Betelgeuse swallowed a large object, such as another star, in the past. This could have sped up the star's evolution and made it more likely to go supernova. A recent paper has found something new about Betelgeuse's brightness cycles. The paper found that the longest period, which is 2,200 days long, could be the main cycle for Betelgeuse's pulsations. If this is the case, then the star's brightness could change significantly in the future. This is still just a hypothesis, and more research is needed to confirm it. However, it is an exciting development that could help us better understand Betelgeuse and its future. Overall, the brightness of a supernova would be a mixed blessing. It would be a beautiful and exciting event to witness, but it would also be a challenge for astronomers and animals. What makes Betelgeuse an astronomical gem is not just its potential to go supernova, but the unique opportunity it presents. This colossal star, with its remarkable size and proximity, grants us the privilege of capturing its essence in breathtaking detail. Unlike distant twinkling points of light, Betelgeuse reveals itself as a radiant disk through the lens of our telescopes. It invites us to witness its luminous variations and grasp the subtle dance of its light as it teases us with its hidden secrets. But here's where things get even more fascinating. The supernova display won't vanish quickly. No, it will linger in our night sky for several years, gradually fading away like a distant star in the distance. Yet there may be moments of resurgence, a burst of renewed brilliance before its light softly dissipates, bidding farewell to its place in the constellation Orion. While the supernova poses no threat to us, it may perplex certain creatures who navigate by the moon's gentle glow. With this additional cosmic light, they may find their bearings thrown off and their nocturnal paths slightly altered. But the impact won't be limited to the animal kingdom. Astronomers and stargazers alike will face new challenges in studying our universe. Observing the night sky during moonlight periods can be tricky, and a blazing supernova will only add to the complexity. Yet the allure of this celestial spectacle will draw the attention of countless telescopes and researchers, who will eagerly adapt their observations to capture the magnificence of Betelgeuse's final act. The anticipation is palpable as astronomers and stargazers eagerly await the grand display of Betelgeuse's supernova. The stage is set, and the universe holds its breath in anticipation of this extraordinary event. But what can we expect when this stellar giant unleashes its explosive might? First and foremost, let's put any concerns to rest. Earth is safe from harm as Betelgeuse is situated at a comfortable distance. While the supernova will undoubtedly captivate our eyes, it won't outshine the moon or the mighty sun. Nevertheless, it will cast its ethereal glow, illuminating our nights and making its presence known during the day for an entire year. Imagine the mesmerizing sight of Betelgeuse's radiant remnants casting gentle shadows upon our world. This cosmic spectacle isn't just a fleeting moment. Oh no, it's a performance that will unfold over several years. Initially, the supernova will dazzle us with its brilliance, gradually fading into the depths of the night sky. There may be moments when its luminosity reignites, momentarily reclaiming its former glory. However, as time passes, the once familiar star in the Orion constellation will fade away, leaving us with cherished memories of its stellar brilliance. Scientists have found that Betelgeuse's brightness cycles are similar to what is seen in stars that are near the end of their lives. This suggests that Betelgeuse could go supernova soon. If Betelgeuse does go supernova, it would be the nearest supernova to Earth in centuries. The explosion would be visible to the naked eye and would be a very bright event. However, it is important to note that this is still just a hypothesis. More research is needed to confirm that Betelgeuse is going to go supernova. Even if Betelgeuse goes supernova, it is unlikely to be dangerous to Earth. The star is about 550 light-years away, so the explosion would not be as powerful as a supernova that is closer to us. The first thing we would notice is a burst of neutrinos, tiny particles that do not interact with matter, so they would not harm us. After the neutrino burst, we would see a very bright object in the night sky. The explosion would be as bright as the full moon and visible during the day. The brightness would last for a few weeks, and then the object would slowly fade away. The explosion would also release a lot of dust and gas into space. This dust and gas would block out some of the light from other stars and could cause short-term changes in the climate. However, the effects would be relatively minor. While this celestial event won't pose any direct danger, It may perplex certain creatures that rely on moonlight for navigation. Amidst this grand cosmic performance, astronomers face their own set of challenges. Observing the night sky is already a delicate endeavor, particularly when the moon shines brightly. A supernova of significant brightness further complicates matters. Yet the allure of capturing the celestial spectacle surpasses any obstacles that may arise. Scientists will adjust their telescopes, fine-tune their instruments, and seize every opportunity to witness and document the evolving beauty of Betelgeuse's supernova. While the James Webb Space Telescope may not be able to directly observe Betelgeuse due to its overwhelming brightness, fear not. A network of observatories, both on Earth and in space, eagerly awaits this momentous event. Armed with a plethora of cutting-edge instruments and techniques, they are poised to uncover the mysteries hidden within the celestial fireworks. Together, they form a global alliance, united by their passion for unraveling the secrets of the universe. However, amidst this celestial spectacle, Betelgeuse had surprises in store. By mid-February 2020, its brightness stabilized, remaining constant for over 10 days. Just as we thought the dimming event had reached its conclusion, Betelgeuse's behavior took yet another turn. 5 days later, the star ceased its dimming altogether, confounding astronomers and leaving them intrigued by its unpredictable nature. It was a puzzling twist in the cosmic narrative, a plot twist that kept us on the edge of our seats as scientists embarked on a quest for answers. A study conducted on February 24, 2020, shed light on the possible causes of Betelgeuse's enigmatic fading. It was revealed that the star's dimming was likely a result of large-grained circumstellar dust obstructing its radiance. This dust, acting as a cosmic veil, cast shadows upon the star's brilliance, adding to the mystique of its cosmic performance. The research, utilizing advanced measurements at submillimeter wavelengths, dismissed the notion of dust absorption significantly influencing the dimming phenomenon. Instead, it suggested that massive star spots could be the driving force behind Betelgeuse's fading. These vast regions of turbulent activity on the star's surface, akin to sunspots on a grand scale, introduced a captivating element to the unfolding cosmic drama. The theories that had been brewing in the scientific community took a step closer to the truth. The notion of a cold spot on Betelgeuse's photosphere, an elusive anomaly, gained further validity. In a symphony of scientific discourse, the initial hypotheses gained strength and clarity. It was believed that the dust was born from the very essence of the star itself, as its gas emissions cooled and coalesced into delicate particles that painted a transient masterpiece in the heavens. Scientists have made great progress in understanding the universe thanks to technological advancements. The Hubble Space Telescope was able to help scientists study mysterious cosmic bodies, and the James Webb Space Telescope revolutionized our understanding of black holes, dark energy, and the fate of stars. In the year 2022, their gaze pierced the veil of uncertainty, revealing a wondrous spectacle, an awe-inspiring surface mass ejection. Like a stellar phoenix rising from the depths, Betelgeuse unleashed a torrent of material, as if shedding its luminous skin. This expelled matter, cooling and condensing over vast distances, birthed the ephemeral dust that now veils the star's resplendence from our earthly observatories. The fading of Betelgeuse has finally ceased, allowing the star to reclaim its position among the brightest luminaries of the night sky. Its brilliance, shining 100,000 times brighter than our sun, stands as a testament to its stellar grandeur despite its vast distance. But such brilliance comes at a price. A fleeting existence fueled by the rapid consumption of energy. Betelgeuse's inevitable fate looms. A depletion of fuel, a collapse under its immense weight, and a cataclysmic explosion, an awe-inspiring supernova. For a brief period, Betelgeuse will blaze with unprecedented radiance, rivaling the brilliance of a full moon day and night. Its brilliance will captivate the hearts and minds of observers across the globe. Moreover, as Betelgeuse approaches the end of its lifespan, the possibility of a supernova event looms on the horizon. Although the timing of this cosmic spectacle remains a subject of intense debate, Betelgeuse exhibits two cycles of dimming and brightening, with the second cycle occurring every 5 years and lasting approximately 100 days. During this cycle, the star's outer shell expands and contracts, causing fluctuations in its diameter and average temperature.